Moving to the next thing. Okay, the characteristics of particles of matter. So the particles of matter are very, very small. What do you mean particles of matter are very, very small? Huh. Okay, so here there is another one more thing. Elements, compounds, mixtures, everything sort of matter. What is elements? Very good. Substance that is made up of one type of atom. Okay, so for example, O2. What is O2? Oxygen. He, helium. He, helium. H2, hydrogen. So these are all elements. So in O2, what happens? There is two oxygen is there. So if two oxygen is present, means both are same type of elements. Okay, atoms. That's fine. So what happens? This is an example of element. What is compounds? More than two. More than two atoms. Okay, it is more than two elements. Say for example, if I'm taking, it can be different also. Okay, NaCl, sodium chloride. Sodium is an atom, chlorine is an atom. So what happens when they are comprising together? This NaCl is an example of compound. Okay, so here you can see this oxygen. In this oxygen, two atoms of oxygen is present. O2 is a element, two atoms of oxygen combined together, two atoms of oxygen is same. But here both are different. Sodium, chlorine, both comprises and forms sodium chloride. That is our table salt. Okay, yes. What is mixtures? Substance mixed together. Let him speak. Like this, like let him say. Compounds can be physically. Compounds cannot be physically. Compounds cannot be physically separated. Mixtures can be physically separated. Now there is actually two homogeneous mixture. What is homogeneous mixture? Sugar. Yes. Homogeneous and homo means hetero means different. Okay. So same in the sense. Do you know what is the solution? What is the compounds in the solution? The solution contains solvent and solution. Okay. So this solvent will be always water, that is right. It will be always in a more quantity or less quantity. This will be always in a more quantity. Okay. And this solute will be always in a less quantity. Okay. So now in this homogeneous mixture is nothing but this solute will be completely dissolved in this solvent. Okay. Say for example, sugar solution. Take a sugar solution. So in a beaker, when the water is there, if you are adding sugar, what happens? Completely dissolved. Correct. So the water, what happens? The particle space will be there. In the particle space, no one gets filled. Okay. Huh? More number of space. Okay. Same. Okay, very good. That's a good answer. So now, here, what happens is this solute is completely dissolved in solvent is a homogeneous mixture. Example, your super solution. And second one is salt solution is an example of not salt solution is also homogeneous solution. And another one more parameter you have to note is solute will always changes its physical state after it is just dissolving in the water. So before you're adding the sugar into the solution, it is a solid or liquid or gas? Solid. After you're adding into the beaker, it has changed its physical state into liquid. Okay. So this is a homogeneous mixture. Heterogeneous mixture means take a sand. Okay. Dissolve it in a water. Completely dissolve it in a water. So what happens at that case? Okay, so what happens there? Whether the sand is completely dissolved in the water? No. What happens is sediments will be settling down in the bottom layer of the beaker. So in that case, the sand is changing its physical state? No. Yes or no? No. So what happens in this case? Here, the solvent is not dissolved in the solvent. Completely it can't ionize or completely it can't dissociate. That is homogeneous mixture and heterogeneous mixture explanation. Clear with this one? Okay. So now this comes under a mixture. So actually the general example of mixture is nothing but your air. In your air, oxygen gas is present, hydrogen gas is present, nitrogen gas is present, carbon dioxide is present, helium is present, everything is present. It is nothing but an example of mixture. Clear with this one? Element, compound, and mixtures. Now we are moving to our next slide. Characteristics of particles of matter. Okay. So what you according to your syllabus, what do you know about the characteristics of particles of matter? How do you say particles are very, very small?
Because we can see them.
Naked eye. Have you seen what do you mean by atom? It's very, 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 very small. It's actually very, very minute. You can't even see it with the naked eye. There is an instrument known as mass spectrometer. Okay. So that mass spectrometers, there is only 2 instruments that is available in India. Exactly. With that only we can see it is actually very, very, very small entity. Once we add. Yeah. Very good quantum. Okay, so what happens if it is very, very, very small? We can't say. Likewise, see, if in this chalk, it is made up of matter. The particles are arranged. If I am taking this much of piece, if I am taking here, see, and here also you can see millions and millions of particles will be there. In the small piece, millions and millions of particles will be there. If I am again destroying, if I am again taking, so what happens here also millions and millions of particles will be there. You can't see it in your naked eye. Okay, when you keep on breaking the matter, at one point you can't break it. That is known as atom. Clear with this one? If you're just taking the matter, when you keep on breaking it, at one point it is indivisible. So atom is indivisible. That is why a universal statement, atom can be neither created nor destroyed. You can't create atom, you cannot destroy it. Clear with this one? Yes. So likewise, in matter also, all the particles will be very, 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 very small. Okay. Of course, if, according to the physical state, the particles arrangement can differ, but how the particles will be, it will be very, 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 very small. And coming to the second one, the particles of the matter have spaces between them. Is it having spaces? Solid is having spaces? Yes. How? Very little amount of space is there. What happened to you? All fine. Okay. So it is having a very, very, very little amount of space. In liquid, moderate space. Moderate space. In gas,